Hey everybody, Mr. Voikin here, and we're going to take a look at the Unit 3 unit conversions section of the review package, and we'll start with question number 25. And this is taking a number, 0 point, how many zeros are there? 1, 2, 3, 4, 5, 6, 7. Looks like 1, 2, 3, 4, 5, 6, 7 zeros, and then a 6, 9, 7. So we are going to convert this into scientific notation, and the way scientific notation is written is there's one number in front of the decimal place, followed by whatever numbers are there, times 10 raised to the power of n, raised to the power of something. And basically, if it's a decimal number, it's going to be a negative number, and if it was a number like 26, which is 5, 1, 8, and then there are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 zeros. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 zeros. That is going to be, again, 5.18 times 10. Now, because this number is larger than 1, the power is going to be positive right here. Okay, so basically what I want to do is count the number of jumps it took to get from wherever the decimal is to where we want it to be. So 1, 2, 3, 4, 5, 6, 7, 8 jumps. So that would be raised to the power of negative 8 in this case. So 6.97 times 10 to the negative 8. And if we take a look at this one, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. That'll be times 10 to the power of, now we don't need to write the little plus sign, it'll be 10 to the power of 14. Okay, and quickly we'll look at number 27. Which is taking 521.2 E6. Now, E6 is just a different way of writing 521.2 times 10 to the 6. Now, it's already raised to the power of 6 here. And notice that in the example above, as I moved the decimal to the left, the exponent increased, so it went positive. So this one down here, where the decimal is there, it's not in the correct position. So remember, we want to see it as 5.212 times 10. Well, how many spaces are we moving it? 1, 2. So move 2. So we need to add 2 to that. So it's going to be times 10 raised to the power of 8. Okay, now, as we're allowed to use calculators in this this exercise, or on this test, you can, knowing how to use your calculator is going to be very beneficial. So if you have a TI-84, there is a button on your TI-84 that says mode, and if you go to mode and you go find where it says what type of numbers it's going to display, you can choose this one right here for scientific notation. Okay, and now if I go type in this first number, so remember there's 1, 2, 3, 4, 5, 6, 7 zeros and a 6, 9, 7. So 0 point 1, 2, 3, 4, 5, 6, 7, 6, 9, 7, and you can see it displays the answer right there. That's 6.97 times 10 to the 8. You don't need these last two decimal, or these two zeros that are right there. The next one was, what did we say? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 zeros. So it's going to be 5, 1, 8. And 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 zeros, and it gives us the answer that we have right there. So knowing how to change your settings on your calculator will basically verify that you've done all this work correctly. Now this number here, 521, if we want to write down E6, or if we see a number that says times 10 to the 6, we can't write times 10 to the 6. We actually use this double E button here. So for this one here, I would write it like this, 521, and then hit the green button, the double E, which puts a single E right here, and then I just put 6. And you can see it converts it into scientific notation at 5.21 times 10 to the 8. All right, everyone, we're going to take a look at question number 29. So this time we are converting from 567.9 millimeters into meters. So you'll want to use the number line that is on this formula sheet that you will have on the test. So notice at the top, I'll just go over this really quickly, that the Pythagorean theorem is here. Side 1 squared plus side 2 squared equals hypotenuse squared right here. Remember that side 1 and side 2 will always be shorter than the hypotenuse, and that's usually laid out as a squared plus b squared equals c squared, and c is the hypotenuse. A and b can be either one of these sides right here. Below that are the right angle triangle trig formulas, sine, cosine, and tangent. And here's the metric number line I was talking about, and below that we've got a conversion chart. On the left it's imperial to imperial, and on the right it's converting between imperial and metric. So sometimes there won't be a direct conversion, and you might have to use 2 or 3 of them to get to where you want to go. Okay, and then below here we've got basic geometry formulas. So we've got area and perimeter of a square, a rectangle, circumference and area of a circle, and showing that diameter is twice the radius and radius is half the diameter. And then how to figure out the area of a triangle. So base times height divided by 2. And then we've got the surface area and volume of specific shapes, and you'll use this to calculate any shapes that are on the test. Okay, so let's take a look right here. Remember, we're going from millimeters to meters. So that's starting right here. This is the unit is meters. So it's deci, centi, milli. So we're starting right here and we're going to meters, which is to the left, 1, 2, 3 jumps. Okay, so literally the chart tells us to move to the left 3 units. So we're going to take this decimal right here and we are going to move it 1, 2, 3 units to the left. So the answer for this is going to be 0.5679 meters. Okay, let's take a look at number 31. So 31 says we have the number 4, 5, 2, 3, 3, 3, 6, 9 millimeters, and take that to kilometers. Okay, so if I bring this over again, where are we starting out? Here at the millimeters, and where are we going to the K for kilometers? So that's going to be 1, 2, 3, 4, 5, 6 steps to the left. So again, we're going to take our decimal, which in this case is at the end there, and we're going to jump it 1, 2, 3, 4, 5, 6 times. So what we end up with is 45.23339 kilometers. Okay, now let's take a look at one more right here, which is number 33. Okay, in this case, we're going to be going from centimeters to inches. Okay, so it says we have 9,880 centimeters and convert that into inches. Inches is also abbreviated with an IN and can also just have a double prime like that. Okay, so for going from centimeters to inches, that's metric to imperial, so we can't use this number line right here. But if we look on here, it tells us that 1 inch is equal to 2.54 centimeters. Okay, so basically 1 inch is equal to 2.54 centimeters. So I can set this up like a ratio. And then I'm going to make it equal to another ratio that has inches on top and centimeters on the bottom. Now, if we look at what we have here, we've got 9,880, but we don't know how many inches we have. So essentially, the 9,880 will go with the centimeters, and X will go where the inches is. Okay, now we just want to cross multiply. So X times 2.54 is 2.54X. 1 times 9,880, and I put an equal sign here, equals 9,880. Now I need to isolate this X on that side of the equal sign, which means I need to get rid of the 2.54, so we've got to get it over to this side right here. So what we're going to do is just divide this by 2.54, divide by 2.54. The 2.54s cancel, leaving us with X equals, now I just punch this into my calculator, so 9,880 divided by 2.54, and it's giving the answer to me here in scientific notation, and you could put it in scientific notation if you wanted to. It depends on what the question states. But if you needed to put it back to decimal, you could either do it by hand, or remember, we just go to mode and change this back to a fixed number, and then I just hit enter again, and so it tells me it is 3889.76, and that is going to be in inches. So IN or INCHES. Now, the question might also state where to round that. So if it says to round it to 2 decimal places, again on here, if I go into mode, you may have noticed that I've got it rounding to 2 decimal places, but if I put more, it's going to provide those for me. So when I hit enter again, you can see there are more decimals there. So if I was going to round to 2 decimal places, yes, it's 3889.76. If we need to round to 1 decimal place, it's going to be 3889.8 inches. Okay, question number 35. We're going to be converting between metric and imperial again. So we're going from 8.5 kilometers or kilometers, whatever, to inches. Okay, so we want to take a look at this chart and see, can I get from kilometers to inches? So there's kilometers, but it's going to miles, and here's kilometers. It's only going to miles right there. So we're going to have to do a couple steps. So I can go from kilometers to miles right here, and I could either use this conversion on the right or this one here on the left. And once I'm in miles, I now need to get to inches. Okay, well, if I want to get to inches, I guess I could, if I can get down to centimeters, that'd probably be the fastest way to do it. So first, take this 8.5 kilometers and take it to inches, and then from inches go to centimeters. Okay, so I'm going to use unit analysis for this one, and you should know what that is. So unit analysis is when you're taking 8.5 kilometers and you're multiplying it by a fraction, putting the units that we're trying to get rid of on the opposite of the original one there. So kilometers is on the top, it goes on the bottom, and I'm going to go, say, to meters. Okay, and I know that 1 kilometer is 1,000 meters. Okay, now the kilometers will cancel, but I'm at meters. But I'm trying to get to inches. First, I'm going to go to centimeters next. So I'm going to multiply this by, again, meters on the bottom, centimeters up top. 1 meter is 100 centimeters. Okay, so now that I'm at centimeters, because the meters are going to cancel, I can go to inches. And we're just going to multiply by centimeters on the bottom, inches on the top. And I know that 1 inch is 2.54 centimeters. So I write it out like that. The centimeters cancel, and I'm left with inches, which is the units that I want. So now, basically, on the calculator, we're just going to type in 8.5 times 1,000 times 100. So everything that's on the top gets multiplied, and everything that's on the bottom gets divided. Divide by 2.54, enter, and we get that 8.5 kilometers equals 334,645. Now 0.66929. So let's round it to 1 decimal place in this case, which would be 0.7. And don't forget to put your units. That is necessary in the answer. There you go. All right, let's take a look at question number 39. This one's quite simple. I just wanted to point out one thing here. Make sure that you notice that they're asking for the total surface area of a cube. So we know a cube is a 6-sided object and all sides are the same. But notice that the units are in square millimeters, so they want it in millimeters squared. But notice that the lengths that were given are in centimeters. So the only thing that's tricky here is that if you read this question and use the numbers 9 instead of 90, because 9 centimeters is equal to 90 millimeters. So basically, the cube, each side is 90 by 90. And when we punch that into the calculator, 90 times 90, we get 8,100, and that is millimeters squared. But because there are 6 sides, I just multiply it by 6. So times 6, and we get 48,600 millimeters squared. Ooh, put a little square there. That's sort of cool. Squared. Final answer. Okay, so we're looking at number 41. A baseball has a radius of 36.5 millimeters. So it has a radius, and a baseball is a sphere. Okay, so we've got this sphere, and it's got a radius which is going from the center out. So the radius is 36.5. Okay, now these are actually very easy questions, because basically all we have to do is just grab the formulas right here for surface area and this one for volume. So I'll put this on the screen. I'll just write it down really quickly. So surface area of a sphere equals 4 times pi times r squared. And the volume of a sphere equals 4 over 3 pi r cubed. And this can be rewritten as 4 pi r cubed divided by 3. Probably an easier way to sort of punch that into the calculator. So really all we have to do is take this number that we have here of 36.5 and just shove it into that r right there, and shove it into that r, and the question's done. It's just a calculator exercise, really. So what are we going to do? We're going to take surface area equals 4 pi 30, what is it? 36.5 squared. And on the calculator, 4, and we want to find pi, which is right here, so second pi times pi, and then I want to do 36.5 and squared. And we can see we get an answer of 16,741.547. And now if we're going to round to 1 decimal place, that will be 16,741.5. And don't forget our units. So we're talking about millimeters. So it's millimeters, and because it's surface area, it will be squared. So there's that one. The other one is just as simple. Volume equals 4 times pi times 36.5 cubed raised to the power 3. Divide by 3. Okay, now depending on the calculator you have, it could be a good idea just to put a bracket around there so it calculates the top of this ratio first and then divides by 3. Okay, so on the calculator, if I start with a bracket, I'm going to go 4 and pi 36.5. Now, some calculators will have a cube button. On this one, I got to put this little hat and then type 3, and then I need to sort of jump down using the arrows right here, and that's the end of that. So I'll put that in a bracket, and then I will just divide by 3. And so we get the volume, the volume equals 203,688.82. And if I'm going to round that to 1 decimal place, it'll be 203,688.8 and millimeters. And because it's volume, it will be cubed. Don't forget those units. Okay, I'm going to jump back to question number 38. And what does it say? A box is 29 inches deep. So basically we have this box right here, and it is 29 inches deep, which means from the top down, that is 29 inches. Okay, and then it says we have a bat, and here is the bat. And the bat is 762 millimeters. Now we got 2 different units here, and the question is saying, will this bat fit into the box properly so that we can basically close this lid? Okay, so let's basically convert either the 29 inches into millimeters or the 762 millimeters into inches. Okay, so I will take the inches one right here and convert it to millimeters. So we're going to go 29 inches, and we're going to multiply that by, and we're using data analysis here again. Remember that inches will go on the bottom so that the inches cancel, and my new units that are on the formula sheet here, remember that 1 inch is 2.54 centimeters right there. So I can now write 1 inch is 2.54 centimeters, but what are we trying to get to? We're trying to get to millimeters here. So now I'm going to multiply by centimeters on the bottom, millimeters up top. The centimeters will cancel, and I know that 1 centimeter is 10 millimeters. So it's only 1's on the bottom, so basically we're just going to multiply the top through. So I get 29 times 2.54 times 10 equals, and we got 736.6. So this is 736.6 So that is less than the length of the bat. So the bat will not fit in the box. Okay. Okay, let's take a look at question number 42. So this is going to be one of the more difficult ones if we're calculating the surface area. So a square-based pyramid is basically this shape right here. Now, it can be rectangular-based or square-based. If it's square, it's going to have the same length as the width. Now, you can see on this side it's width. There should be an L under there for the length right there. So here's the formula for surface area right here. L times W, that's the area of the base. And 1/2 A times L, here's A, and remember that's L, that's a triangle right there. So it's basically the area of that triangle right here multiplied by 2, because there's one on the front and one on the back. And then the other side is W and S. And again, that would be the height of that triangle is the S, not the height inside the pyramid. That's a different height that would be used in your volume. So we want to use this S for the height of the triangle right here, times the W, and then again divide by 2. That's the area. And then because there's another one on the other side, we multiply it by 2. Now, because it's a square-based pyramid in this question, we could just eliminate the second part and multiply it by 4, because we would calculate the area of the triangle and then multiply it by 1, 2, 3, 4 triangles that are the same size. Okay, so I'm going to write down that formula, which is going to be surface area equals length times the width plus 4, in this case, times 1/2 A times L, which is basically the area of the triangle right there. Okay, now if we look at the square-based pyramid as it sits, it's going to have this height that's in the middle, and all the sides are going to go down from that middle to that point right there, to those points. And then in the question it says that this is 52 long right here. Now if we take that directly over to the outside and then we sort of create this sloped line, this slanted line, and we have a 90-degree corner right there. So we have a right angle triangle. And on the right angle triangle, if I look at it, now because this total length right here is 52, half of it will be half of that, which is going to be 26. So that is 26, and my height is given to us at 45. So basically what we need to calculate is that C right there, and we will just use Pythagorean's theorem, and that's going to be C squared equals A squared plus B squared. C equals the square root of A squared plus B squared. C equals the square root of 45 squared plus 26 squared. And C equals, well, we just want to shove that in the calculator, and I've already done it up here, 45 squared plus 26 squared, and that equals 51.97115. So I'm going to leave it with at least 5 decimal places here, so that I have more precision in my next calculations. Okay, and that is, again, we just calculated that slant right there, and that in our formula sheet is this A length or this S length right there. Okay, so basically what I want to do is write this formula out with the values substituted in. So I've got surface area equals length, which is 52, times the width, which is 52, plus 4 times 1/2 times the A, which is the, again, that sloped line that we just figured out. So that's going to be times 51.97115 times the L, which is the length, which is, again, 52. Okay, and now I just need to put that into my calculator. Okay, so I'm going to clear the screen. I'm going to put a bracket and go 52 times 52, close that bracket, plus 4 bracket, and now I can basically use the fraction in here, or I can just go 1 divided by 2 for a half, or go 0.5. Okay, times 51.97115, and again times 52, and close the bracket, and there's our answer right there. So the surface area equals, now if we're going to round this to 1 decimal place, this is sort of a tricky one because the 9s are going to round to a 10, which basically becomes a 0. So this 8 needs to, that's right here, will become 8109. 8109.0 if I was rounding it to 1 decimal place. And we're talking about area, so what are the units? It says centimeters and squared. Okay, now what about the volume? Well, according to our formula sheet, it's length times width times the height, which is the height in the middle here, divided by 3. Okay, so the volume equals length times width times height divided by 3. So that's going to be 52 times 52 times 45 divided by 3. And that doesn't get any simpler right there. We just go 52 times 52 times 52 divided by 3. Oops, I gotta clear that and do that again. 52 times 52 times 45 divided by 3, enter, we get the volume equals 40560 and centimeters cubed. So there is the final answer for our surface area, and here is the final answer for our volume. Okay, last question. We are going to solve the, what does it say to solve there? Round to the nearest tenth and solve the surface area and the volume, and this is a cylinder. Okay, so we need to take a look at our formula sheet here again, and there is the cylinder, and there's the surface area, and there's the volume. So surface area equals 2 times pi times r squared plus 2 times pi times r times h, and the volume equals pi r squared times h. Okay, and this will be really simple. The only part of this question that's might trick somebody is when you see the height is going to be this 6 centimeters right there, so that's the height, but that's the diameter, not the radius. You can see that this line, this red line, is going all the way through, so that is the diameter. So, and you notice that the questions are all asking for radius in that situation. So how do we calculate the radius? Well, very simply by radius equals diameter divided by 2. So radius equals 4 divided by 2, which equals 2. Okay, and the height is 6. So now we just simply go surface area equals 2 pi 2 squared plus 2 pi 2 times 6. Okay, and for the volume, I would just go volume equals pi times 2 squared times the height, which is 6. And doesn't get any simpler than that. We just, oops, I think I was covering that work when I was doing it by the formula sheet there. Now we just got to punch this in. So I'll clear that. It's 2 pi 2 squared plus 2 pi and 2, and now I'll have to put the 6 in brackets or put times, and we get surface area equals 100, and they said round it to 1 decimal place, so that's 0.5, and the units are centimeters, and because it's surface area, it is squared. Final answer. And the bottom one, which is the volume, is going to be pi times 2 squared times 6. And we get volume equals 75. And if we're going to round that to 1 decimal place, it'll be 0.4. The units are centimeters, and cubed because it is volume. Final answer.